Hi guys, I'm really sorry I'm missing chemistry class this week, but I promise I'll be back next week to help you. I decided the easiest way to help you learn the material this week would be to make this video. Someone should have passed out the note sheet to you in class, so if you could find your note sheet and take notes as I work through these problems with you, hopefully you will get a good understanding of them. If at any time I'm going too fast for you, the nice thing about this video is you can always pause it and you can rewind it and go back and do the problem several times. Alright, so what we're going to be talking about this week is something called stoichiometry. And it's written here at the top. It's kind of a big word. It's pronounced stoichiometry. And what that word actually means is it's just relating quantities of different substances in a chemical reaction. So for example, in this reaction, we're relating aluminum and oxygen gas, and we're making a product. And so we're trying to figure out how much of each of those things we need. Notice here, I put that this is the single most important topic that you will learn in this class. And the reason for that is you just use it so much in college. In a lot of things you do in your college chemistry course, you will use stoichiometry. So it's important that you understand it. We're going to do a quick review of one of the problems that you did last week so that you really understand how to convert from one thing to another in a chemical reaction. This says how many moles of product? I want you to circle the word product. We're talking about the thing that's made, the product. How many moles of that can be made if we start with 9.5 moles of aluminum? So what I usually do is I write what we start with. They said we're starting with 9.5 moles of aluminum, and we want to know how many moles of product. So I put a question mark there. Okay, and we did problems like this last week, but for a quick review, you're going to take what you're given and put it over 1. 9.5 moles of aluminum over 1. And to convert to product, we need to use these coefficients out in front. There's a 4 in front of aluminum, so for every 4 moles of aluminum, we can make 2 moles of aluminum oxide. Okay? We're just using these big numbers out in front. And this step that you just did, maybe put a box around it, that's called the mole ratio. For every 4 moles of aluminum, we can make 2 moles of product. Notice that I put the aluminum on the bottom because in order for it to cancel, it has to go on the bottom. We cancel those and we're left with moles of aluminum oxide. And so we just need to do this problem in our calculator. So I'll take 9.5 times 2, and I'm going to divide that by 4. And so my answer should be 4.75. Okay, that's my final answer there. Okay, let's go on to the next section with something called limiting and excess reactants. I just have kind of a silly question for you. I want to know how many cars can I make from these parts? I gave you 6 car bodies and 40 tires. How many cars can I make? Okay. So if you think about it, each one of these cars needs how many tires? Every car should have 4 tires on it. Okay. So for each one of these cars, we're going to use 4 of those wheels. Okay, So you could do this a couple ways. You could color in, well, I used up 4 for that car, 4 for that car, okay, and so on and so forth if you wanted to color them all in, and you could see how many tires are left. Or you could say, well, I have 6 cars, and they each take 4 wheels, so I'm going to need to use 24 of those tires. Okay? So when you think about this problem, which one do we run out of first? Do we run out of cars or do we run out of tires? We run out of cars first because we really only need 24 tires, and they gave us 40. Okay? So we can only complete 6 cars. We have 6 car bodies, and once we run out of bodies, we can't really make any more cars. So we're able to make 6 cars, and I think we have 16 tires left over, or something like that. Okay, so what I want you to see from this problem is that even though you're given 2 things reacting together, one of those reactants is going to run out first. And in this problem, our cars ran out first. And as soon as our cars run out, we can't make any more product. We're stuck at 6 cars. The tires are extra. We have plenty of tires to make cars with. We even have some left over. Okay, so that's a lot like what happens in chemical reactions. One of your reactants will run out, one of them will be extra. And when one of them runs out, your reaction stops. Okay, so let's define those terms down here. The limiting reactant is the one that limits the reaction. It limits the amount of product that can be formed, because when it's completely used up, the reaction stops. Okay, and we abbreviate limiting reactant LR. The excess reactant, ER, is the one that we have left over, or the one that we have extra, excess. Like our tires, we had a lot of it. Okay, so that's what those 2 terms mean. Let's use that to do this problem below. It says an iron manufacturer starts with 1,256 moles of iron ore. Let's circle that, because that's what we have. I'm going to even write it underneath here. We have 1,256 moles of FeS2, iron ore. We want to know how many moles of oxygen are going to be needed in order to react with it. So how much oxygen will we need in order to react with those moles? Okay, so this is just a conversion problem like we've been doing. We'll take our 1,256 moles of iron ore, put it over 1, and then you need to use those coefficients. You have a 4 in front of iron ore, and you have an 11 in front of oxygen. Okay, the 4 has to go on the bottom so that your moles of iron ore cancel. Okay, so in your calculator, you're going to do 1,256 times 11, because it's on the top, and then you're going to divide by 4. You're going to get 3,454 moles of oxygen. That's how much is needed. Okay, If we wanted to label the limiting reactant and the excess reactant, the one that they gave us is limiting the reaction because they only gave us that much to start with. And we want to know how much oxygen is needed. So we really could have as much of that as we need. So that one's excess. So you could label those if you want. The second question they ask us is how many moles of iron oxide will be made? That's this one. Okay, so we want to know, well, how much product could we make? Let's start with what they gave us again. We know we have 1,256 moles of iron ore. That's what they gave us to start with. And we're going to use that one because that limits the reaction. When it's gone, the reaction stops. Again, we're going to use our coefficients. They put a 4 in front of iron ore. And if you go over here to the product, there's a 2 in front of iron oxide. Okay, so that's saying for every 4 moles of iron ore, you can make 2 moles of product. And that's what we have. 4 moles of iron ore makes 2 moles of product. Cancel your iron ore and you can do that problem in your calculator. So I'm getting about 628 moles of iron oxide. Okay, and just so you know, MOL is just the abbreviation for mole. You can put the E on it if you want. You'll just see in a lot of chemistry classes and chemistry books, sometimes they just put MOL. So you can do whatever's easiest. All right, go ahead and flip your page over to the back. Okay, so we just did a conversion problem together, and I would like you to try this one by yourself. I'm going to help you get it set up, and then I want you to do the calculation on your own. So it says silver, this guy right here, tarnishes when it's exposed to dihydrogen monosulfide. And every house has a little bit of that in it, but it usually only has a small quantity. Thus, dihydrogen monosulfide is always the limiting reactant in this reaction because there's not very much of it, so that's going to limit how much product we can make. It says if a silver spoon has 0.0012 moles of tarnish on it, this is tarnish. That's the formula for tarnish, silver sulfide. We want to know how much of that gas it was exposed to. Okay, so the only number they gave us was this many moles of tarnish to start with. So you should always write that underneath the correct place, 0.0012 moles of tarnish. We want to know how many moles of dihydrogen monosulfide. So your question mark should go here. Okay, so I'd like you to pause this video and see if you can convert using your coefficients this many moles to that many moles. Okay, now that you've had a second to do that, you should know that we always take the number we're given and we put it over 1. That's how we should start every question. For our mole ratio or our conversion step, we're going to use the coefficients that are out in front. For every 2 moles of tarnish, how many moles of dihydrogen monosulfide can we make? 2. There's a 2 out in front. Okay, our moles cancel. And because we have 2 over 2, that's really the same thing as 1 over 1. So this question is going to end up having the same answer that we started with. Because if you multiply by 2 and you divide by 2, you get the same thing. Okay, so that one kind of worked out nice. All right, so if you have any questions about mole ratios at this point, I would really suggest going back and watching the video again for the calculations, because this step here should become very easy for you. You use the numbers out in front, just make sure you put them in the correct place. Okay, we're going to do one last one together and then we'll do something new. If a chemist adds 5.61 moles of silver chloride, put it under silver chloride, to excess zinc, so they're saying this one is the excess and this one is going to be our limiting. We want to know how much silver can be made. Okay, so that looks like the problems that we've been doing. You're going to start with your 5.61 moles of silver chloride over 1. And then you're going to use your coefficients to go from here all the way over to there. 2 moles of silver chloride gives me 2 moles of silver. Well, again, the 2's kind of cancel out, so we get 5.61 as our answer. Okay, so those two problems were pretty easy because our mole ratio was very simple. Okay, in this last question, we're going to do something that applies directly to a lot of your foods and medicines that you use on a daily basis. So when chemical companies decide to make something that you're going to eat or drink or consume, they need to know how much of the reactants to add in order to get the product they want. And of course, they don't want to add too much because then they'd be wasting money. So this is kind of a real-life application of where do people actually use chemistry in real life? Well, a lot of people that make the things that you consume use chemistry on a daily basis. So let's read through this question. It says citric acid with this formula. So this one's citric acid. It's used to make fruit drinks, jams, jellies. It's kind of sour. If a fruit drink manufacturer needs 1.4 times 10 to the 5th moles, they need that much product, how much of the reactants will they need to make that? So because they didn't say which reactant, we actually need to do all 3 of them. Okay? So the way you're going to set that up is we're going to go from product backwards to reactant using those coefficients. So let's put our starting number over 1. So we start with that many moles of citric acid. And let's convert that to our sucrose first. Let's go from product and figure out, oh, well, how much of this sugar do I need to start with? So your coefficient in front of your citric acid is a 2. For every 2 moles of citric acid, I need to start with, and if there's no number out in front, remember it's just a 1. I only need 1 mole of C12H22O11. Okay, so we did that one. You're going to set it up the exact same way to figure out how much water you need. Okay, you still have a 2 out in front of your citric acid. And now we're going to water. And there's nothing out in front of water either, so we'll assume that only 1 mole is needed. And then in the last one, Again, we'll start with our 1.4 times 10 to the 5th moles. And we're going to say that for every 2 moles of citric acid, we need 3 moles of oxygen gas. So this one should have a 3 on the top. 2 moles of this, you need 3 moles of oxygen to start with. Okay, so now you have 3 simple calculations that you need to punch into your calculator. Okay, and I see I have the word mole here. That shouldn't be there. 1.4 times 10 to the 5th. 1.4 times 10 to the 5th. So let's punch in this first one together. Remember on your calculator, when you have things in scientific notation, you're looking for the E button. And on this one, on this calculator, it's like a little EE. So I'd put 1.4, find your E button, 1.4 e to the 5th, and it wants me to divide by 2. So my answer for the top one is 70,000. Okay, I'd like you to punch in these last 2, get your answers. That's what you should get. You need 70,000 moles of sugar, you need 70,000 moles of water, and you need 210,000 moles of oxygen in order to make this amount of citric acid that your manufacturer wanted. Okay, so that's how you set up a longer problem. It's not hard, and I won't give you a lot of them because I do see that it takes quite a few steps, but you just set up each step individually, and you go from what they're giving you to what they're asking. What they're giving you to what they're asking. Okay, so I hope this tutorial was clear enough for you to follow in order to do your homework. Again, I promise I'll be back next week, and if you have any questions before the quiz, we can go over those. We will have a quiz next week, and we'll do our lessons like we have been doing. So I hope you guys have a great week, and I will see you soon. Bye.